Welcome to Pulse of Tech by SEAP, Pune's leading technology podcast from SEAP, the city's premier platform for tech organizations, delivering cutting-edge discussions and insights.
Hi, I am Parijat Sardesai and you are listening to Pulse of Tech by SEAP. Today's guest, Dr. Yogesh Haribhau Kulkarni, has spent over 2 decades in computer-aided design, backed with a bachelor's, master's and a PhD degree in mechanical engineering with a specialization in geometric modeling. And today he's solving complex problems with the help of neural networks and machine learning. This is a kind of tech story which you don't want to miss. So let's dive in. Hi Yogesh.
Hi.
So, this is one of the questions which I usually start with always, but let me rephrase it in a different way for you. Okay. There have been multiple resets in your career, right? Correct. And very exciting to see that kind of a journey for someone. I'm really inspired to see that kind of a journey. Can you, just throw some light on that?
Sure,
right?
sure. As you rightly said, Parijat, first of all, thanks a lot. Thanks for the opportunity. So I've got few twists and turns in my career, and I've actually talked about it at many places.
Okay.
And one of the main places that I've talked about it is in my TEDx talk. Okay. So it's called Hit Refresh. We can give.
Yeah, I want to talk about that, but yeah.
So there I've explained all my resets, but that talk is in English. So maybe what I can do, those who want to see it in English, they can refer to the TEDx talk. But here maybe I'll talk about it in Marathi. Is that okay?
It works for me.
Wonderful. So I'll give my background first and then talk about these 4 resets. Maybe a little longish answer.
No problem at all.
मी मेकॅनिकल इंजिनियर आहे.
ओके.
COEP 94 बॅच.
ओके.
आणि त्याच्यानंतर US ला गेलो तिथे MS करायला. आणि त्या काळापासून CAD कम्प्युटर एडेड डिझाईन या फील्डमध्ये मी आहे. सॉफ्टवेअर डेव्हलपमेंट, रायटिंग अल्गोरिदम्स. तर मास्टर्स त्याच्यात आणि त्याच्यानंतर बॉस्टनमध्ये नोकरी, मग परत आलो. मग इथेही CAD इंजिनिअरिंग अशा प्रकारच्या कंपन्यांमध्ये काम करत होतो. सगळं नीट चाललं होतं व्यवस्थित. काय सॉफ्टवेअर इंजिनियर, सिनियर सॉफ्टवेअर इंजिनियर, मग लीड वगैरे असं सगळं नॉर्मल चाललं होतं. पण अचानक एके दिवशी मला ॲड दिसली की एक नवीन स्टार्टअप सुरू होत आहे. एकच माणूस US मधून आलेला आहे आणि तो एक स्वतःचा सेटअप सुरू करतोय. तर हे पाहिल्यानंतर मला वाटलं की आपण हे जे नॉर्मल करतोय ते असंच लिनियर मोशननी जाणार पुढे. तर आपण एक उडी घ्यावी म्हणून मी तेव्हा ठरवलं की या स्टार्टअपला जॉईन करायचं.
ओके.
तर मी तिथला पहिला एम्प्लॉई, मॅनेजर आणि नंतर मीच. नंतर ऑफकोर्स काही जण आली. मग आम्हाला खरं जागा नव्हती. मग एखाद्याच्या भाड्याच्या जागेत 2 टेबल टाकून वगैरे अशी सुरुवात केली. मी आधी एकदम व्यवस्थित सगळं चाललेलं, छान ऑफिस वगैरे.
लाईक एक्झॅक्टली व्हॉट फ्लॅट हायरार्की.
फ्लॅट म्हणजे एकदमच फ्लॅट, तो आणि मीच. तर तसं सुरू केलं. इव्हेंच्युअली काम ठीकठाक केलं आणि आम्हाला एका मोठ्या ग्लोबल जायंटनी ॲक्वायर केला. मग आम्ही पुन्हा चांगली लॅडर करायला लागलो. सो दॅट वॉज अ ग्लोबल जायंट. आम्ही तिथेही चांगलं काम केलं. असं पुन्हा नीट झालं, मॅनेजर झालो, साईट लीडर झालो. तेव्हा असं वाटलं, म्हणजे तो पहिला रिसेट होता स्टार्टअपला जम्प करणे. तेव्हा आता दुसरा किडा मनात वळवायला.
94 मध्ये स्टार्टअपला जम्प
नाही, नंतर जॉईन केलं. एक जॉब झाल्यानंतर साधारण 2005-06 मध्ये मी स्टार्टअपला जॉईन केलं.
तरी 2005 मध्ये मी करिअरही स्टार्ट नव्हतं. सॉरी.
यू आर गेजिंग माय एज नाउ. सर तेव्हा असं वाटलं की आपलं काय बॅचलर झालंय, मास्टर्स झालंय, पण एक डिग्री राहिलेली आहे. तेव्हाच ठरवलं की आपण आता ती उडी करायची. आणि मग मी PhD करायचं ठरवलं.
ओके.
आणि मग मॅनेजरशी बोललो. अमेरिकन मॅनेजर होता माझा, त्याच्याशी बोललो. मग 6 महिन्याचा प्लॅन केला आणि 2013 मी पुन्हा बॅक टू स्कूल. हा दुसरा रिसेट. आधी एकदम प्रॉपर मॅनेजर, मोठी टीम. आणि मग म्हटलं आता दुसऱ्या दिवशी स्टुडंट, नो इन्कम, नथिंग. आणि पुन्हा अभ्यासाला सुरुवात, मॅथमॅटिक्स. तर तो हा दुसरा रिसेट. तेही ठीकठाक चाललं. मग रिसर्च झाला, व्यवस्थित पेपर्स पब्लिश झाले. आणि असे पेपर्सच करत असताना माझा PhDचा विषय पण CAD, कम्प्युटर एडेड डिझाईन, सरफेस डिझाईन बेसिकली, तोच ठेवलेला होता. आणि आम्ही सगळे ते अल्गोरिदम्स लिहायचो, स्टेप बाय स्टेप हँड कोडेड अल्गोरिदम्स असायचे. पण तेव्हा एक पेपर असा समोर आला की त्यांनी हँड कोडिंग न करता एक ऑपरेशन नुसता डेटा देऊन केलं, लेबल्ड डेटा ज्याला म्हणतात,
ओके,
इनपुट आणि आउटपुट दोन्ही.
ओके, सो ट्रू स्टार्ट ऑफ डेटा,
मशीन लर्निंग. सो दॅट इज मशीन लर्निंग. मग एकदमच डोक्यात प्रकाश पडला की दिस इज द फ्युचर. मग तेव्हाच ठरवलं की आपण हा तिसरा रिसेट करायचा. मग माझी PhD संपली, थिसिस डिफेंड केला आणि मग मी सरळ स्विच केला. म्हणजे आधी सो कॉल्ड हायेस्ट डिग्री इन दॅट फील्ड आणि दुसऱ्या दिवशी एकदम नवीन बॅक टू फ्रेशर. मशीन लर्निंगमधला मी फ्रेशर झालो, कोर्सेस केले. अजून एक चांगली गोष्ट केली, मी शिकवायलाच लागलो तो विषय. म्हणजे जेव्हा आपण शिकवतो तेव्हा जास्त चांगला समजतं असं करून शिकवायला आणि कॉर्पोरेट ट्रेनिंग वगैरे असं करायला लागलो. आणि मग काही ठिकाणी फ्रीज जॉब्स केले,
ओके,
स्टार्टअपमध्ये वगैरे. माझा पोर्टफोलिओ बिल्ड झाला. मग अशाच एखादा टॉक चालू असताना मग एक मला बोलवणं आलं आणि मग कंपनी जॉईन केली. हे 3 रिसेट झाले. आणि मग चौथा रिसेट जेव्हा आला की या कंपनीत ते ठीक चाललं होतं पण मशीन लर्निंगचं काम होतं. आणि मग म्हटलं पण एकच डोमेन असतो एखाद्या कंपनीत, खूप काही असं वेगवेगळं करता येत नाही. तर ज्या आठवड्यात मी 50 वर्षाचा झालो त्याच आठवड्यात मी जॉब सोडला मग. आणि मग बियॉन्ड माय ओन. मग तेव्हापासून मी कन्सल्टन्सी सुरू केली मशीन लर्निंगमध्ये आणि ती आता व्यवस्थित चालू आहे. तर मशीन लर्निंगची कन्सल्टन्सी पण करतो AIची आणि COEPला शिकवतो ॲज अ व्हिजिटिंग फॅकल्टी. अशी ही जर्नी. बरेच 4 रिसेट्स आहेत प्रायमरली, पण ऑल वेअर फुलफिलिंग इन दॅट सेन्स अँड ऑल वेअर सॉर्ट ऑफ डिझाइन्ड दॅट वे.
आय मीन माझी मराठी चांगली नाही, सो आय विल कंटिन्यू बट आय विल ट्राय माय लेवल बेस्ट. सो every reset which is there in your career is not like a minor shift, it's like an orbital change, right? What keeps you inspired doing
so minor meaning what we call in plus change, right? From C to C++ is a sort of an addition.
C to C++ is a orbital change, but okay.
From procedural to object oriented.
Right.
Plus in the sense is incremental. Incremental operator. So if you are changing from say TCS to Infosys to Wipro, one level up, that's plus change.
Correct.
But these were orbital in the sense mode change from normal company to startup, from CAD to ML, from job to no job. So I think there are 2 reasons primarily. First of all, there is a thinking, if at all this doesn't work, am I okay? I'm completely okay. I'm a hands-on person, technical guy. I can code even today.
Till today,
even today, given a problem. So there is sort of a technical support. And the other was family support. Later in the life, my wife was working. So there was no issue as such. Whatever the lifestyle that I had, financial issue was not there. Everything was taken care. So these are the 2 reasons: technical reason and a financial reason. So on those 2 fronts I was completely okay. So that's why I could do this sort of jumps, orbital changes.
And I think financial reason might not be the only reason. Your technical expertise, and I think that's very 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 inspiring for all of us, that if you know the field technically, there is no harm in trying something else, because you know you can go back to what you were doing, right? So
plus there is some I mean there is a risk, of course. When I changed from CAD to ML, there was a big shift. Because the domain was new, it was a different kind of mathematics. I was aware of mathematics that was in CAD, but then I had to put some efforts actually. I became a fresher again. Right from doing everything from scratch. And then of course there's a sort of a mental makeup also you have to have. Nobody will give you the earlier salary, earlier money, right? Because you are producing a fresher's work, will not pay you basically, isn't it? That is the mindset you have to cater to.
So my statement around financial stability holds no good now.
So you have to have your financial security, then you can take the jump and take the hit that way.
Okay, got it. So as an adjunct professor at COEP, you just spoke about that, right? How do you ensure that students not only focus on the theory part of their curriculum, but also, because you have been talking about being hands-on throughout your life, right? how do you first of all motivate them? How do you focus on that? I mean, it will be very good to hear about that perspective.
So this journey of being professor actually started about 30 years back, 97, 98 kind of time frame. So that time I used to teach geometric modeling, my CAD field only as a visiting faculty. Still I'm a visiting faculty only, but during PhD period where in COEP itself, then I did full-time teaching as a student, fellow student, PhD student. So that time I was doing geometric modeling, but later after my PhD, as I myself shifted to machine learning, so then I started teaching machine learning, but coincidentally not for computer science, but for mechanical engineers. So mechanical and production department.
Machine learning for
mechanical
That's
engineers.
Very interesting.
So that's where this application that you just hinted about comes into picture.
Okay.
So machine learning per se is actually another problem solving technique only.
Okay.
So you used to write algorithms to solve a particular problem, but now if you have data, supervised data, labeled data, then if you feed the data, then you apply machine learning or deep learning techniques. So that's the only difference. You're solving the same problem.
Okay.
So that's why catering ML for mechanical engineers was not a problem.
Yeah.
So I taught theory, whatever 6, 7, 8 algorithms that typically supervised algorithms, unsupervised, and then dimension reduction, all those algorithms. But the examples, the projects were related to mechanical engineering. So how to predict glass hardening, something related to that. What would be the stress about this data set? So all problems related to mechanical engineering were given as assignments or projects. Okay. So theory and then practical was of their domain. So that's why I could cater even to production department. So that way it was made possible. One myth that I have to dispel here, that people think that AI is for comm science guys. So that's not the case at all. It is there for all engineers. In fact, it is there for artists and lawyers and medical people also. Only thing, they need not know the theory behind, but how to use it and what does it mean. When you say regression, what does it mean?
Okay.
When you say clustering, what does it mean? But it will be applicable to your data only.
Oh.
That is the idea.
Okay. So you spoke about AI for legal purposes, right? So your research in legal text mining is also very compelling, right? And from there, we rule-based AI to DL to generative AI, this entire journey. Right. I would want to hear about that.
Sure. So actually, when I shifted to machine learning, one of the first projects that I looked into was related to legal document processing. Actually,
complex field, and it's a very complex field.
So I was not from legal background. I am not from, but still. So there was a conference in ISC Bangalore, I think. So they had floated a problem to find, given a Supreme Court or judgment, how to find a referring judgment or similar judgment so that you can refer it, basically.
Yeah, so you don't have to go through that. Those books behind the lawyer's background, right?
So this is called precedence search. So can we do it automatically? So that was a problem there. So we sort of solved it that way. So my interest in legal document processing was started there itself. Then when I joined a job, it was more or less similar thing, a legal document processing. Maybe I'll take some example. So if you are processing a contract, what you need typically is you need some important entities in it, okay, to make it searchable. So you have lots of contracts lying in your folder. And then if you want to find out which contracts are expiring next month, how do you address this issue? Unless somebody reads through them and notes down that document 1 has ended this, document 2 has ended this, unless that is written down, extracted and written, you cannot search, right? Yeah. That way, just from the folder. Okay. So this is called as entity extraction. Okay. So that used to happen manually. Somebody would just read parties in the contract, start date, end date, contract value, many things. So the company that I worked for actually worked in this domain, and they would do discovery of such entities. Okay. So that time we started initially with say rule-based algorithms, meaning having some hand-coded logic. Typical examples are if you want to find an email of party 1. So there is something called as regular expressions with which you can just find the patterns, matching patterns and find the emails. I'm just giving an example. So rule-based way is also possible. Same entity extraction problem can be solved machine learning way if you have labeled data. So this is the sentence in which this is the party. This is the sentence, this is the party. And there are models like CRF, conditional random fields and all, which you can employ to do this automatically. So little more enhancement from manual to rule-based to machine learning. Now, these machine learning can be, this problem can be solved by neural networks also. By networks like LSTM and RNN and LSTM, sequence-based methods. So their neural networks are used for the same problem, same data. Little better results. And finally, so this, we started doing not just deep learning, but generative AI, that is prompt engineering. So same problem, extracting important entities from document was done initially manually, then rule-based, then machine learning, then deep learning, and now it is generative AI, meaning prompt engineering. So this is the journey we took in that company. So all pluses and minuses of each approach is to be taken into account while building the final professional solution. Because I'll just give you some idea. In rule-based, you have written the logic. So if there is a problem, you can debug it. You can just put a breakpoint and debug why it is not working. Slowly, as you progress from machine learning to deep learning to generative AI, this debuggability, the ability to debug actually goes down, although the power increases. Just take an example, if you're using prompt engineering to extract entities, ChatGPT or whatever, these are some of the examples, it's called few shots, and then give me the entities. But if it does not give the entities, what do? You can change some parameters like temperature, top P, top K, whatever, some parameters are available. But that's about it. You cannot change the model behind, right? So idea to debug is very, very less, although it is very powerful.
With deep research, can you try doing that?
So now there are different models now. First ones are called as answering models. Let's call them answering. System 1 kind of thing.
Correct.
But the reasoning models can reason also. So this is system 2, system 1 and system 2 kind of models. So they are of course far better. But there is of course a chance of hallucination, meaning giving wrong results. So there, what do? So the whole idea is you have to use these approaches judiciously and maybe have all the approaches. So one which is definitely possible with definitive patterns, do rule-based. If there is data available, machine learning. If there is too much data available, deep learning. And if nothing is there, then of course prompt engineering. So this is the progression of approaches you can use.
Nice. So we just spoke about like neural networks, right? And your mid-curve NN project is very fascinating in that line, and it has geometric modeling as well in it. I would really want to understand about it, and I'm sure all our audience is very keen to know about it.
Cool. So, Parijat, I'll give you a background. Okay? This is actually my PhD topic. It's called mid-surf. Mid-surf is meaning surface in the middle. Right? So, when you have shapes which are thin-walled shapes, meaning like sheet metal, where thickness is constant, right? And in other areas are little more. So there, when you model such parts in CAD package, computer-aided design package, you also test them there. So if you put some load on it, will they buckle, will they break? Such things are done in computer software itself. So there, if you have 3D shape, thin-walled sheet metal shape, you typically use what is called as FEM, finite element method. There you put brick elements, brick shape-like elements. Everything is meshed. Then you put load, and then some mathematical calculations happen, and the bending is calculated. And if bending is little more than expected, then you say that this load is too much. Let's reduce the load. This is how car bodies, aeroplane bodies, wherever you see sheet metals, or even things like this, if you see the table like this, where there is a thickness, constant thickness, such things, such analysis is done. By the way, analysis is done for most of the shapes, but the special case that I'm talking about mid surface, is related to sheet metals, thin walled shapes.
Okay.
There, instead of brick elements, meaning 3D elements, you can use surface elements, meaning rectangle elements or 2D elements.
Okay.
Why? So, in a thin walled shape, you have a top surface and a bottom surface. If you are able to compute surface in the middle, okay, it is sort of equivalent to the 3D. So instead of solid, that middle surface is considered equivalent in the sense, instead of 3D brick elements now, you just apply surface elements on the mid surface. So initial 3D analysis becomes 2D surface analysis. Why it is done? Of course, less number of calculations, because instead of 8 nodes in a brick, you are only calculating for 4 nodes. Little technical here, but still, number of calculations reduce. And the results are almost equivalent. So you are saving on compute, calculations, but the results are not hampering too much. That's why for this special case of thin walled components, sheet metal components, this technique is used. And this technique is being done for 30, 40, 50 years now. Okay, because it is saving. But even in that case, and most of the CAD packages, computer-aided design packages, give this functionality. Given a thin shape, calculate the mid surface and then apply load later. But even now, there are problems. For given complex sheet metal shapes, the surfaces patches are calculated okay, but not the connections. Connections they miss.
Okay.
Sometimes gaps are there, so sometimes small patches remain. Then somebody has to sit and patch them manually. I'm just giving you some background of this problem. So it is a complex problem. And as I said, this has been going on for years. Even today, manual work is done and it takes weeks and weeks to patch, because it is very essential to save the cost. Okay, so this was my topic, PhD topic.
Why would somebody want to do it? I mean, in industrial application?
So, if you are designing a car body, instead of the sheet metal shape, which is 3D shape, if you compute the surface in the middle and do that analysis, finite element analysis, it is equivalent to the 3D analysis. So you are saving on dimensions, saving on calculations, but the results are almost equivalent. That's why we do it. So that was my topic. Of course, I did it somewhat better than the previous one, but the problem is still unsolved. So after my PhD, once I started knowing about neural networks, later I thought that I should employ this technique now for this problem. Actually, 3D shape is very challenging for even neural networks, because it is not vectorizable. You cannot create vector embeddings out of the shape. This is a little technical, but that's fine. Text can be converted to vectors by embeddings. Images are already numbers, so they can be used for as input to neural networks, but shapes cannot. So that's a major limitation. So I decided that instead of 3D problem, mid-surface problem, can I approximate it and solve a similar 2D problem? Meaning, imagine that you have a L kind of shape, L profile. Its mid-surface, if I extrude the L, it will be like channel like L, right? Its mid-surface will be like in the middle. It is equivalent to computing a mid-curve of a profile, L profile. If the L profile is like this, if I compute the L mid-curve in it and extrude that, that becomes a mid-surface. Is it correct? Maybe I should have shown pictures, but anyway. So the problem is, now the problem is reduced from 3D to 2D.
Yeah.
Given a L shape, just imagine L profile, compute mid-curve in the middle. Right? Now that's the problem. I'm just taking L as an example. It can be any shape, any thin shape. This also problem is very challenging. And right from 1965, people are writing papers on it. Even this is not solved, because the connections is basically the problem. So now the question is, if I have labeled data, meaning L-shaped profile and it's mid-curve, if I have pairs like that, hundreds of pairs, can I employ neural networks? This becomes a supervised problem because labeled data is there, and use neural networks for this. But then there are challenges in the sense the input shape and the output shapes are different. Their lengths are different. So there are no ready graph to graph networks available. Then I decided, let me convert that problem to even simpler problem. Even in 2D, if I take an image of profile and image of a mid-curve, then it becomes fixed size. Both dimensions for both input and output are same. 28 by 28, 28 by 28.
Correct.
Now there are ready networks available.
Okay. So the scale stays the same, but
dimensions remain the
scale
same.
is the same,
Correct,
so you
correct.
can, yeah.
Now it has become a solvable problem. And this repository, that project that you're talking about, Mid-curve NN, is about that only.
Okay.
Mid-curve by neural networks. As of now, I'm diluting the problem from geometry to image so that it becomes solvable. But later, once the mid-curve is predicted,
Then
you can
will
take
scale
it back to surface.
Then you can scale it.
Then you can scale it.
Okay.
So this is a long technical answer, but I think if at all anybody is interested, they can visit my GitHub repository called Mid-curve NN. There's only one in the world, so you can easily get it.
Yeah, we can find it from your name as well. Okay. Thanks.
Later on, actually, now that I'm sort of conversant with generative AI prompt engineering, another approach that I've taken is, instead of converting geometry to image, can I describe that L shape or T shape or M shape in language? Meaning as a JSON, list of points, list of lines, as a JSON, meaning JSON file format, like everybody's sort of familiar with the dictionary file format, but in language, in text. Now it becomes text to text problem, which is solvable. So both image domain problem and text domain problem is what I'm working on research wise.
Okay, nice. And, and we spoke about now, so I will steer it according to that, right? We spoke about generative AI now, and I think everybody is talking about generative AI, right? So you've also done a lot of work in terms of regional or indigenous language models. So, what does that mean? How is that? Holding good to today's era.
Correct. So most of the LLMs, large language models that you see, so ChatGPT is just the interface. So there is an LLM, large language model behind it, and GPT 3.5, 4, whatever is available.
Correct.
Similarly, all these chat-like interfaces have models behind.
Correct.
But predominantly, they have been trained on English data.
Correct.
And of course, some European languages where data is available in abundance on internet. So it has got digitized and they are using it for training. That's not the case with Indian languages much. Hindi may be, but not much. So all these language models, if you just use them as is, after certain level of complexity, simple answers it can give, but then it starts fumbling, right? You can easily see that. Hindi, forget Marathi. Marathi, it won't just probably get it. At least the Pune Marathi, it won't get it. So the main lacuna, main problem is data for training. Okay. So there are quite a few efforts going on, both on government side and of course on the private side, to create Marathi data sets. Or Indic language data sets, all Indian languages.
So government investment
also. So there are projects like Bhashini, and there is some effort going on in IIT Bombay, IIT Madras. Sort of privately funded government initiative.
Yeah, we spoke about it with Dr. Prashant Pansare earlier in our earlier episode as well. Yeah.
So they are building Indic LLMs, Indic languages, language models. So there, one of the effort I was part of is called as AYA, not like Marathi AYA, but AYA, where we volunteered to create data sets. So I was part of Marathi dataset creation and one of the top contributors to that. Coincidentally, they have open sourced all the data set also. So this project was by Cohere, called Aya, and their charter was to create data sets for sort of unrepresented languages.
Okay.
So that whole data set is now available. So now I think more efforts we can see from government as well as individuals, researchers and companies.
But the model inherently stays the same.
No, now what we can do, there are two ways of course to do this, is to train model from scratch. Meaning just take the neural network, have your own data, indic data, language data as input and build model, which is little compute intensive and you probably need millions of dollars to do this.
Correct.
So there is another way of doing this, is to take a base model, say open source model like Llama 2, Llama 3,
2, yeah.
have your indic data, Marathi data, Hindi
Feed it
data,
back
and
to
then fine tune it. So fine tuning is definitely possible, and many people have done that. So it behaves as if it's a Marathi model or Hindi model.
Okay.
So that's where I think most of the guys who are less on cash are going there.
Okay. So agentic systems, right? And you've been exploring Microsoft's Autogen framework on that, right? And we've been talking about agentic systems also, I mean, in bits and pieces. So first of all, what that exploration is all about, and are there any ethical concerns which everybody is worried about nowadays, right?
So Parijat, maybe I'll give some background. So we talked about LLMs, large language models, and interfaces like ChatGPT, right? You ask question, it gives answer. That's about it.
Correct.
But then why these agents? Agents are actually more than LLMs, more than question and answer.
Correct.
They also plan and act. So this is the addition. They do have LLM behind to do what is called as reasoning.
Correct.
If somebody asks query that I want to go for vacation to Manali, right? ChatGPT like interface will give you a plan as is. But what agent will do is, agent will plan and start booking also. It will fire APIs for booking. So it will plan
Take some
and
action
take
as
action.
well. Yeah.
So they also have what are called as reasoning models behind, because the reasoning models are coming in the picture. The agent with the help of LLM behind can plan the actions, break down the task, plan the actions, sequence them. Maybe if they have sub-agents, they can the main agent can delegate to different agents. One is looking at airline bookings, one is looking at bus booking, hotel booking, whatever,
Correct.
n things,
Correct.
sightseeing. So it can delegate also, get the answers. Once the answers are there, then they have what are called as tools. Tools are nothing but action items, right?
Correct.
Basically Python functions in code language, but they can call APIs to do things. So they can act. Once everything is done, then of course you can review, evaluate whether everything was done properly.
That's why the ethical concerns
And
are
then ethical concern is, now that they can act,
yeah.
should they be allowed to act?
To act. Yeah, that's why
on your behalf.
Yeah.
So LLM was sort of okay, but there are also ethical concerns. So in ChatGPT, if you ask questions, it will answer. But won't it give rubbish answer? Won't it give inappropriate answer? It can.
Yeah, and people act on it.
And then people act on it. So there are ethical concerns in normal chat interface also, but here there are more because it is acting on your
Machine
behalf.
is acting now. Yeah.
So best way to mitigate this is to have human in loop as of now.
Yeah. Always.
Don't give complete control.
Yeah.
But get the power of LLM, get the power of its tool selection, planning, everything. But have that okay in your hand.
Yeah.
If everything looks okay, then do it.
Correct.
Especially this is true not for like if you want to write automatic posts on LinkedIn or Facebook or whatever. That is okay. You
Yeah.
can later on edit it if at all something burns.
Everybody does that.
But in case of some medical applications, legal applications and financial, the agents have to be used very judiciously.
Correct.
You have to have human in loop because there are compliances and the costs are more.
Correct. Okay. And about Autogen?
Yeah, so Autogen is actually one of the frameworks.
Okay.
So Autogen is of course related to agents. So it's a Microsoft framework, but open source. Okay. So there you can define agent. So agent 1, who is a booking agent, agent 2, who is a sightseeing agent.
And they can work
They
with
can
each
talk
other.
to each other. So
Okay.
there are different agentic patterns. So some are sequential patterns, one after another. One can do hierarchical, one are groups. Everybody collaborates, talks to each other. All these sort of collaboration patterns are available in the framework.
Okay.
You just have to say this is a group chat and agents are defined and then they
talk to
start
each other.
working.
Okay.
So this is possible. But there are many other frameworks which are also popular. N18 is also very low code, no code
Okay.
platform which is very popular. LangGraph is
Yeah.
a graph based
Correct.
open source platform. So many platforms have come about and they are going to be in fashion. For the right reason and also for the wrong reasons, because they are sort of wow factors. Huh?
Yeah,
Somebody is thinking and then giving you answers.
Yeah, now there are meta agents who
Meta
can
agents.
create agents.
Great agents.
Yeah.
But then, of course, this whole thing we have to take it with a pinch of salt because as LLMs hallucinate, agents using LLMs will hallucinate and take wrong action.
Take an action as well. Yeah. till it was generating, it was fine.
was okay, correct.
Now it is taking an action
Taking
also.
an action. So, yeah, this we have to be very careful about.
Okay.
But this is going to stay.
Okay.
And of course, if you have heard of biggies like Salesforce and all, so their 50% of work is getting done by agents,
Correct.
agent force and all. All
Correct,
these
correct.
systems are in place now. This is going to stay, and this is going to be better and better every day.
Okay. So now we'll go to your book, and actually we spoke about regional data sets and the LLMs improving with that data set. What inspired you writing this book in a regional language? And I mean, I really want to
Correct.
hear about it.
So, being born and brought up in Pune, you cannot escape being a Puneri. As a normal sort of educated Puneri person does, I started writing about. मी मराठीत लेख लिहायला सुरुवात केली पहिल्यांदी. जेव्हा मी ट्रेनिंग्स द्यायचो मशीन लर्निंगचे वगैरे, तेव्हाच काही वर्तमानपत्रातनं मागणी आली की तुम्ही या विषयावर आम्हाला लिहून द्याल का. मी सुरुवात केली बघ संपादकीय पत्र असतं म्हणजे सेंटर पेज असतं, इथं जे लेख असतात ते त्या वर्तमानपत्राच्या सगळ्या पुरवण्यांमध्ये जातात. अशा पेजमध्ये लिहायला सुरुवात केली. AI रिलेटेडच लिहायला सुरुवात केली. कालांतराने सकाळमधनं तशी रिक्वेस्ट आली. सकाळ हे इथलं जे महत्त्वाचं वर्तमानपत्र आहे, बरेच लेख लिहिले आणि मागच्या वर्षी त्यांनी सांगितलं की आपण हे कधीतरी न असेल न लिहिता, जसा विषय येईल तसं न लिहिता एक आपण सदर सुरू करूया. सदर म्हणजे कॉलम, वीकली कॉलम सुरू करूया. मग तिसरा मेंदू नावाचा कॉलम, आपल्याला 2 असतात, तिसरा हा ॲडिशनल इंटेलिजन्स, असं सदर सुरू केलं. मग त्यात मी दर मंगळवारी लेख लिहायचो AIच्या वेगवेगळ्या टॉपिक्सवर, वेगवेगळ्या रूपांवर. म्हणून ॲक्च्युली हे पुस्तक खरं तर पहिल्यापासून लिहिलेलं पुस्तक नाही आहे, फ्रॉम स्क्रॅच ज्याला म्हणतात तसं नाही आहे. तर ते कंपायलेशन आहे, ते त्याचं संकलन आहे सगळ्या लेखांचं. मग ते सगळे पूर्वीचे लेख घेतले, सकाळची परवानगी घेतली आणि ते कंपाईल करून आता हे पुस्तक आलं आहे. मी हे दाखवूया. ठीक आहे. तर AI रुपे असं नाव आहे. तर यात हे आत्तापर्यंत आलेले AI रिलेटेड माझे सगळे लेख त्यात छापलेले आहेत. बेसिकली सेल्फ पब्लिश केलं, मीच त्याचं टाईप सेटिंग वगैरे केलं आणि पब्लिश करून घेतलं आहे. आता या पुढच्या योजना अशा आहेत की याच पद्धतीचं AIमध्ये रिस्ट्रिक्ट न राहता अजूनही जे काही टॉपिक्स आहेत जे इंटेलिजन्स रिलेटेड आहेत, जसं की मेंटल मॉडेल्स आहेत, स्ट्रॅटेजिक थिंकिंग आहे, त्याच्यावर लिहिण्याचा मानस आहे.
ओके. म्हणजे आय कॅन ट्राय इन मराठी, बट आपण दरवेळेस पुण्याबद्दल काहीतरी बोलतो आणि तुमची पुण्याची सगळ्यात आवडती आठवण काय असणार?
आठवण म्हणण्यापेक्षा पुण्याची एक वेगळी खासियत आहे ती म्हणजे काय, बाय द वे मी सदाशिव पेठेमध्ये वाढलो त्यामुळे पेठेतला माणूस आहे. तर तिथं वेगळी गोष्ट अशी की बऱ्याचशा मोठ्या लोकांच्या गोष्टी तिथे तुम्हाला फुकट पाहायला ऐकायला मिळतात, म्हणजे एकदम दिग्गज मंडळी. आणि मी साधं उदाहरण घेतो. लहानपणापासून मला व्याख्यानाला कोणाचं भाषण असेल तर ऐकायला जायला खूप आवडतं, आणि एस्पेशली पॉलिटिकल लोकांच्या. आणि गाण्याचे कार्यक्रम, सदाशिव पेठेत जिथे राहतो तिथे अगदी 10-10 मिनिटावर चांगली चांगली नाट्यगृह आहेत. गाण्याचे कार्यक्रम, नाट्यप्रयोग आणि बऱ्याच प्रकारचे कार्यक्रम, पॉलिटिकल, नॉन पॉलिटिकल, असे सगळे जाण्याचा योग आला पुण्यात असल्यामुळे. तीच खरं तर महत्त्वाची आठवण आहे. म्हणजे अटल बिहारी वाजपेयी असू दे, अडवाणी असू दे, बाळासाहेब तर आहेतच, बाळासाहेब ठाकरे असू देत, ह्या सगळ्यांना मी असं रस्त्यावर बसून ऐकलेलं आहे. गाण्याचे कार्यक्रम, लता दीदी असू दे, हृदयन असू दे, सगळ्यांचे कार्यक्रम ऐकायला मिळायचे. म्हणजे जगात उत्तम काय हे तुम्हाला पुणे 30 मध्ये बसून कळतं. ही त्याची खासियत आहे.
ओके, थँक्यू सो मच योगेश. इट हॅज बीन रिअली अ प्लेजर टॉकिंग टू यू. आय मीन I've learned a lot over this whatever time we have been talking. I would want to like continuously talk to you, but with the limitation of time and resources, we will have to stop here. But again, it was an inspiring talk, and thank you so much for joining us here. And till next time, thank you.
No problem. Thanks Parijat, and thanks to SEAP for the opportunity. Wonderful. Thank you.
Thank you.
With this, we wrap up another episode of Pulse of Tech by SEAP. Hope you enjoyed our conversation on Indic Generative AI and multiple topics related to the same. So stay tuned for another episode of Pulse of Tech by SEAP. Like, share and subscribe. Thank you.